And now we have here the integration of x squared over x squared plus 8 raised to 3 halves dx. Now in this case, we cannot apply the integration rule. We cannot apply this rule into that since we have a, in these rules, we only have square root of u squared minus a squared. And in this case, we have 3 halves, okay? Nor we cannot apply the previous integration rule that I introduced, this trigonometric or inverse trigonometric function, again, since we have square root here in the denominator, and in the problem, we have 3 over 2, okay? So, in this case, we don't have a choice but to apply trigonometric substitution. Now, we have to identify which is u and which is a. In this case, it can be, okay, na hindi tayo gagamit ng completing the square. So, we may not use completing the square here since we don't have variable x, or that is x in the first degree, inside as our base here, or inside the radical. Okay? We have x squared and 8, so therefore, by looking at this equation, we can identify that our u squared here is equal to x squared, and our a squared here is equal to 8. Correct? So, in which our u is equal to x, and our a, that is the square root of 8. So, let's try to change this variable x into function of theta. Again, we need to plot this one in our right triangle, in which our u here, okay, that is x, and take note since we have plus sign in between two terms, so neither of this term is the hypotenuse. So these are opposite and this is the adjacent. So x here, that's the opposite, okay, then the a, that's square root of 8, that is the adjacent, okay? So therefore, our hypotenuse here is equal to the square root of the difference of their or the sum of their square, that is x squared plus 8. Okay, that is the hypotenuse, the length of the hypotenuse. So therefore, let's change everything by first determining or creating a trigonometric function from this right triangle. So we can say that we can use tangent theta here. And our tangent theta is the opposite over the adjacent. And then we can say that x here is just the square root of 8 tangent of theta. But since in our function we have dx, so we need to derive x here, and this would give us square root of 8, that is secant squared theta, that is d theta. So let's change everything here as a function of theta. Then we have the integration of, when we have our x here, our x is square root of 8 tangent theta, so let's substitute it here, but take note it is being raised to 2. Then we have square root of 8 tangent of theta squared times we have dx. Now our dx here is square root of 8 secant squared theta d theta. Then we have square root of 8 secant squared theta. Then we have d theta. And then all over. Now in this case, we can substitute x here as square root of 8 tangent theta. Okay, so you can do that. However, I would like to teach you the other way, and then by looking at the right triangle, we can express square root of x squared plus 8 into trigonometric function, and that would give us, now we know, we can say that it is cosine theta is equal to the adjacent square root of 8 over the hypotenuse square root of x squared plus 8. Correct? This is adjacent over the hypotenuse. That is the identity of cosine theta in a right triangle from SOHCAHTOA. TOA. So therefore, we can say that it is square root of x squared plus 8 is equal to square root of 8 over cosine of theta. Hence, we have x squared plus 8 is equal to 1 over cosine theta is square root of 8 secant of theta. Okay, so we can say that our square root of x squared plus 8 here is equal to square root of 8 secant theta. Okay, now we know that this form, x squared plus 8 raised to 3 halves, can be expressed as x squared plus 8 raised to 3 halves can be expressed as square root of x squared plus 8 Okay, that is raised to the 3, in which we know that x squared plus 8 here is equal to square root of 8 secant theta. Square root of 8 secant theta, then raised to the 3. Okay, so you can use, or you can substitute x here as square root of 8 tangent theta into this, then simplify it further, then it should come up with this form. So this should have the same answer. No, either way, either you get the equivalent of square root of x squared plus 8, or you substitute square root of 8 tangent theta into x, and they have the same answer. So from here, we can say that x squared plus 8 raised to 3 halves is equal to square root of 8 secant theta raised to 3. So we can change this one into square root of 8, that is secant theta, then raised to the 3. Again, the equivalent of this from here, that is square root of 8 secant theta raised to the 3. So we simplify it further, we could say that's the integration of, we have square root of 8 tangent theta squared. Now take note, we can distribute squared both in each term. So we have square root of 8 squared. Okay, so we have square root of 8 squared is equal to 8. So we have 8, then tangent squared theta, times we have square root of 8, that is we have secant squared theta d theta, over, then we have a square root of 8 raised to the 3. Okay, so we have, since we have square root of 8 raised to 3 is the same as square root of 8 cubed, and this gives us, that is 8 squared times 8, and we know that square root of 8 squared is equal to 8, so we have 8 square root of 8 in this case. Okay, so therefore square root of 8 raised to the 3 is equivalent to 8 square root of 8. So we have 8 square root of 8, then that is secant cube theta. So we have here, we can cancel out square root of 8 and 8 here, we can cancel this out. Since we have this secant cube theta here can be break down into 2, in which you could say that it is sine squared theta times secant theta, correct? So we can cancel out here secant squared theta, and the remaining in our integration form is equal to tangent squared theta d theta, over, in the denominator we have only secant theta. Now how are we going to integrate this one? Now we know that tangent squared theta is equal to secant squared theta minus 1. So therefore, we can say that the integration of tangent squared theta is equal to secant squared theta minus 1 over secant theta, then we have d theta here. Then we have, so let's separate these two. We have secant squared theta over secant theta, and then we still have minus 1 over secant theta. Then we have d theta here, that equals to secant squared theta over secant theta is equal to secant theta minus 1 over secant theta is basically equal to cosine theta, since secant theta is the inverse of cosine theta. Then we have d theta. Then we can integrate separately. We have the integration of secant theta d theta minus the integration of cosine theta d theta. And this gives us, we know that the integration of secant theta is the natural logarithm of secant theta plus tangent theta. Okay, so review our video. Now I have the video discussion on trigonometric rule or integrating trigonometric. So we have minus, now we know that the integration of cosine theta is sine theta. Okay, then plus c. Again, this should not be our final answer since our answer is in terms of theta. So we need to replace it by the original function that is in terms of x. So where are we going to look for a variable x that we can use as a substitution for this trigonometric function? Now let's go back to our right triangle here. Since we need secant theta, and we know that secant theta is hypotenuse over the adjacent, that's just the opposite of cosine. Now in this case, our hypotenuse is square root of x squared plus 8, and the adjacent is square root of 8. So we have here the hypotenuse is x squared plus 8, and the adjacent is square root of 8. So we can now use this one, and we also need tangent theta, but we have already determined the value of tangent theta here, that is x over square root of 8. But we need sine theta. So we have sine theta here, that is the opposite over the hypotenuse, that is x over the square root of x squared plus 8. Again, from trigonometric identity, that is the opposite over the hypotenuse of our theta. So we have determined secant theta, sine theta, and tangent theta. Then let's substitute this value to our integration. So we have the natural logarithm of our secant theta here, that is square root of x squared plus 8 over square root of 8, square root of x squared plus 8 over square root of 8, plus our tangent theta here, that is x over square root of 8, x over square root of 8, then minus our sine theta, that is x over the square root of x squared plus 8. Then we have plus c. Okay, so we have now the integration. However, we can simplify it further again. So we can factor out 1 over square root of 8. So we have here the natural logarithm of 1 over square root of 8 times square root of x squared plus 8 plus x. Then minus x over square root of x squared plus 8 plus c. Okay, again, we can break this into 2. That is, we have the natural logarithm of 1 over square root of 8. Then we have plus the natural logarithm of square root of x squared plus 8 plus x minus x over square root of x squared plus 8 plus c. Okay, now we know that we have the answer for the natural logarithm of 1 over square root of 8, that is constant. So we can substitute this as constant na lang. So if we add constant here and constant in the right side, so the answer would be constant. So therefore, our final answer here, that is the natural logarithm of square root of x squared plus 8 plus x minus x over square root of x squared plus 8 plus c. So this is the simplest answer for the integration of x squared over x squared plus 8 raised to 3 halves dx. And then we have last example, we have the integration of x squared, then square root of 25 minus x squared dx. Now in this case, we may not use completing the square since we can identify directly here which is our u and our a. Now in that case, we can actually rewrite this integration into the integration of x squared and square root of, we have 5 squared minus x squared dx. So therefore, in that case, our a is equal to 5. And our u, in that case, is equal to x. Okay, so this is our a, and this is our u. So we can now plot that in our right triangle. So we cannot apply any integration rule to this one since this is not in the form of fraction. So the only thing that we could do here is by applying trigonometric substitution. So first, let's plot that in our right triangle. We have this our theta. Now we know that we have minus sign in between this term. So we can say that our 5 here, this is the hypotenuse. Okay? Then our x, that is the opposite. So therefore, we could say that this one is sine theta, that is the opposite over the hypotenuse. So we have x here is equal to 5 sine of theta, and then you derive x, that is 5 cosine theta d theta. So we substitute this value to our integration because we want to replace this one by trigonometric function. And this gives us x squared here, that is, since we have 5 sine theta as the value of x, so we get 5 sine of theta, that is squared. Then we have a square root of 5 squared minus x here, that is 5 sine of theta, that's squared. Then we have dx. Our dx is 5 cosine theta d theta. Okay, that's our dx. So we have the integration of, we could say that is 25 sine squared theta, correct? And in this case, we can factor out 5 squared here. Now take note, this is 25 and this also 25, so we can take out 25. Then the remaining would be 1 minus sine squared theta, correct? Since again, this one is 25 since we have squared, so this would become 25, and this one is also 25, so we can factor 25 out. Then we copy 5 cosine theta d theta. Then we have here the integration of 25 sine squared theta. Then we have square root of 25 times square root of 1 minus sine squared. This is cosine squared theta, correct? That is trigonometric identity. And 5 cosine of theta d theta. And this one would give us 25 sine squared theta. The square root of 25, that is 5. And the square root of cosine squared theta is cosine theta times 5 cosine theta d theta. So we can multiply 25 times 5 times 5. That gives us 625. And we take 625 out of the integration na lang. And the remaining would be sine squared theta. And we have cosine theta and cosine theta here. Then that would become cosine squared theta d theta. Now, since our sine and cosine here has common exponent 2, then we can take out 2, or we can square them as one term. So we have 625, the integration of, then we have sine theta, cosine theta, then we have squared d theta. Now from our trigonometric identity, that is, we have sine of 2 theta is equal to 2 sine theta cosine theta. So this is from your trigonometric identity. So therefore, since we do not have 2 in this form, so we can say this is what? Sine theta cosine theta is equal to sine 2 theta over 2. Correct? So we can substitute sine 2 theta over 2 in this form. So we have 625, the integration of, we have sine 2 theta over 2. Take note, this form here is being raised to 2. So we have squared. Then we have d theta. So we have here 625 is the integration of sine squared 2 theta over 4 d theta. Then we have 625 over 4 integration of sine squared 2 theta d theta. Now, we have sine squared 2 theta d theta here. Again, we still don't have trigonometric rule or integration of trigonometric rule to this one. However, we can simplify it further by trigonometric identity. Now, what would be the trigonometric identities that we could use this, or we could substitute in this form? Now, we know that if we have sine squared theta, this would give us 1 minus cosine 2 theta over 2. This is again a trigonometric identity. Now, since we have 2 theta here, twice the angle, so we have 2 theta. So therefore, our angle in cosine would become twice as well. So therefore, 2 theta would become 4 theta. That would come over 2. So we use this trigonometric identity in this form. So we have 625 over 4. That is the integration of, that is sine squared 2 theta is equal to 1 minus cosine 4 theta over 2. That is 1 minus cosine of 4 theta over 2 d theta. So we substitute sine squared 2 theta, that is in terms of 1 minus cosine 4 theta over 2. So we have here 625 over 4 times 2, that is 8. Then we have the integration of, so we take 2 outside of the integration, the remaining would be 1 minus cosine 4 theta d theta, and we can integrate them separately. We have 6258, the integration of d theta, minus, we distribute 625 over 8, and this gives the integration of cosine 4 theta d theta. So in this case, we have 625 over 8. Now, the integration of d theta, that is theta, okay, that's theta, minus, now, if we integrate this one is our u, so therefore, our du should be 4 d theta. So therefore, we multiply 4 here, so that this would be our du, correct? So we multiply 1 over 4 outside, so we have 625, 8 times 4, that is 32. Now, the integration of cosine u, that is sine u, and our u is 4 theta, correct? Then we have plus c. Now, again, we have our answer in terms of theta. We need to take back our function of x in this answer. So we know that our theta here, from our right triangle, our theta is equal to arc sine of x over 5. Correct? This one. Okay? So we have 625 over 8, that is arc sine of x over 5. This one is the value of theta, minus 625 over 32. Now, we don't have sine 4 theta in our right triangle, correct? Since our angle only have sine theta, but take note, our theta here is multiplied by 4, so we can just say sine of quantity 4 times the value of our theta. The value of our theta here, that is arc sine x over 5. So we have arc sine of x over 5. And this one is our theta. And this one is 4. Okay? So we have plus c. So this one now is the answer for the integration of x squared square root of 25 minus x squared dx. And that ends our discussion for trigonometric substitution. So if you have question, please don't forget to comment it down. And then for more videos, please don't forget to like and subscribe. Thank you again for listening.